In section 3.5, we'll be learning about symbolic derivatives. So sometimes you're going to be asked to find the derivative of a function that you don't know much about. So we'll just say like f of x or g of x. But sometimes you might know a few points or a table of values or a graph. So in those cases, you use the same differentiation rules we've been learning about, so like product rule, quotient rule, chain rule, etc. And then you evaluate using the given data. So you want to make sure to write out the derivative first using the rules and then plug things in. So in example 1, we're given this table of values. So notice it has values for f, f prime, g, and g prime. And it asks us to find each of the derivatives at x equals 2. So we'll keep that in mind, x equals 2. So in part A, we have h of x equals f of g of x. So we just have these symbols here, the letters that represent the functions. We don't know too much about them. So we have to decide what rule to use. So we see that g of x is inside of f of x, so this is a chain rule problem. And so we can find h prime of x first. So the derivative of the outside is f prime. Leave the inside the same, times the derivative of the inside. But remember, we want to find the derivative at x equals 2, so we'll evaluate at 2. So make sure you write out the derivative first, and then evaluate at 2. So I'm just replacing the x with 2. Then I'm going to use my table of values to fill in. So the first thing I'm going to need to find is g of 2. So g of 2, I'm going to look at the g column and go down to where x is 2, that is 3. So this is really f prime of 3 times g prime of 2. And then I can find f prime of 3, so f prime of 3 is negative 2 times g prime of 2 is negative 1. And so this answer is just 2. In part B, we have k of x equals the quantity f of x cubed. This is also a chain rule problem, just a little bit different. So my outside function is the cubed, the inside is f of x. So when I take my derivative, I would have 3 times f of x squared, but then I still have to multiply by the derivative of the inside. The derivative of f is just f prime of x. So I've done my differentiating, and now I'm going to evaluate. K prime of 2 equals 3 times f of 2 squared times f prime of 2. Now I use my table. F of 2 is negative 4. F prime of 2 is 8. So be careful there. It's easy to accidentally look at the wrong column, like f instead of f prime, etc. So some of this is just, paying close attention to your details. You could leave your answer like this, or you could simplify, you get 384. Just to be clear, I could not leave my answer at 3 f of 2 squared times f prime of 2, because that's not a numeric answer. I at least have to go over the next step of plugging things in, and then I could leave it right here if I wanted. In part C, we have p of x equals f of x times g of 2x. And so in that case, I have these two functions being multiplied, so I know I'm going to use the product rule. But there's also this 2x inside of the g, so I'll have to use chain rule as well. So my p prime of x, derivative of the first part is f prime. Leave the second part the same, plus the first part times the derivative of the second part. The derivative of the second part is going to be g of 2x and then times 2. Now I plug in. P prime of 2 means I have f prime of 2 times g of 2 times 2. That means this is g of 4 plus f of 2 times, this should have been a g prime up here, times g prime of 4 times 2. So f prime of 2, I can see up here is 8 times g of 4, which is 2, plus f of 2 is negative 4 times g prime of 4 is 3 times 2. So I get 16 minus 24, which is negative 8. Okay, part D, we have r of x equals f of 2x over g of x. So I see this as a quotient. I will definitely have to use quotient rule. But I also noticed that f has a 2x inside of it, so I'm going to have to use chain rule like I did in the last problem. So for my derivative, I've got my low, d high. So the derivative is f prime of 2x times 2 minus high, f of 2x. D low, that's just g prime of x. All over my low, which is just g of x squared. Notice that's g of x, not g prime. Okay, let's go ahead and evaluate r prime of 2. So that's g of 2 times f prime of 4 times 2 minus f of 4 times g prime of 2 all over g of 2 squared. Okay, so if I evaluate that, g of 2 is 3, f prime of 4 is negative 1 times 2 minus f of 4 is 0 times g prime of 2 is negative 1 all over 3 squared. So this second part just cancels out because it's 0, so I have negative 6 over 9, which simplifies to negative 2 over 3. In part E, we want to find the equation of the tangent line to the graph of j of x, which is g inverse at x equals 2. So remember, to find the equation of a tangent line, we need a point and we need the slope. So to find the point, I'm going to do j of 2, which is g inverse of 2. Now when I'm finding g inverse of 2, that really means I want to find the x value when the y value is 2 on g of x. So if you look at that table up above, so I'm looking for g inverse of 2. When is g equal to 2? That is at 4. So this is 4. That gives me the point 2 comma 4. To find my slope, I'm going to do my derivative, j prime of x. Remember that formula from the last section? It's 1 over g prime of g inverse of x. And so j prime of 2 is 1 over g prime of g inverse of 2. Well, we know that g inverse of 2 is 4. That's what we actually just found here. So this is 1 over g prime of 4. I can look at the table up above. It tells me that g prime of 4 is 3. So I have 1/3. That gives me my tangent line equation now. Y minus 4 equals 1/3 times x minus 2. So sometimes you're going to be given a graph of a function instead of an equation or a table of values. So here we have the graph of h, which is the solid line, and the graph of j, which is the dotted line, so we'll have to keep track of those. And each one is just made up of 2 straight lines. So in part A, it asks us to evaluate h prime of 5. So when I see h prime, that means slope of h at 5. So whenever I see the derivative, I'm looking for the slope of the line. So if I look at h, that's this line here. It's actually this whole graph, but I'm specifically looking at h of 5, so that's this point right here. And so if I want to find that slope, I can look at the rise over run. So I go up 2 over 3. You could do this with algebra, like using the coordinates, but I think it's easier to just count in this case. So my slope is 2/3. For j prime of 5, so that means I'm going to be looking at j at 5. That's this other line here. I can also use rise over run. So I go down 1, over 3. And so that slope is negative 1/3. While we're doing this, let's go ahead and find the slopes of our other pieces as well. So the other part of j, depending on where we're at, so that has a slope of 2 over 1. So this has a slope of 2. And the other part of h, that piece there, we'll go ahead and find that has a slope of negative 3. So I go down 3, right 1. So we'll have to keep those slopes in mind as we find our other derivatives. So I just wanted to go ahead and label those. So in part C, it tells us that we have a function m of x, which is j of x over h of x, and we want to find m prime of 5. So this is going to start out just the way the last problems did. So we'll use quotient rule to find the derivative. So m prime of x is my low h of x, d high j prime of x, minus high j of x, d low h prime of x, all over my low squared. Now we plug in 5. So h of 5 times j prime of 5 minus j of 5 times h prime of 5 all over h of 5 squared. So h of 5 means the y value on h at 5. So that's the y value here, which is 2. J prime of 5 means the slope on j, that's this green line at 5, which we said before was negative 1/3. Minus j of 5, that's the y value right here, which is 3, times the slope of h at 5, which was 2/3. All over h of 5, which again was just 2 squared. So in the numerator, I have negative 2/3 minus 6/3, that's negative 8/3 divided by 4, which gives me negative 2/3 for my final answer. You could leave your answer right here in that numeric form. Okay, for part D, we have h of x times j of x, and we want to find that derivative at x equals 1. So we will use product rule here. So I'm going to go ahead and rewrite that derivative right here. This is a little bit different format. We're using that Leibniz notation. So when I write this, I'm going to go ahead and find the derivative. So h prime of x, j of x, plus h of x, j prime of x. I'm going to try to fit it in here at x equals 1. It's telling me what the x value is. So that's how I write it when I do the derivative. Sorry, that's a little unclear. This is h prime j of x plus h of x j prime of x. Take the derivative one at a time. Then I can go ahead and plug it in. So it's h prime of 1 times j of 1 plus h of 1 times j prime of 1. Looking at this, h prime of 1 means the slope of h at 1. So make sure you're looking at the right line here. I'm looking at this pink line. That has a slope of negative 3. J of 1 means the y value of j at 1. That's this blue line. The y value is 2. H of 1 means the y value of h at 1. That's this pink line. That has a y value of 3. Times my slope of j at 1. That slope is 2. That's the blue line there. So I have negative 6 plus 6, which is 0. So for part E, we have h of x over 2x plus 1, and we want to find the derivative at x equals 1. So we will use quotient rule here. So I'm going to do my low, d high, minus high, d low, draw my line, square my low, 2x plus 1 squared, and I'm evaluating at x equals 1. So that means I have 2 times 1 plus 1, be careful with your parentheses here, I need parentheses right there, times h prime of 1, minus, I'm just going to put the 2 in front, 2h of 1, all over 2 times 1 plus 1 squared. That gives me 3 times h prime of 1, so that's the slope of h at 1, that was negative 3, minus 2 times my y value of h at 1, which was positive 3, all over 2 times 1 plus 1, that's 3 squared. So I have negative 9 minus 6, negative 15 over 9. I can simplify that a little bit, divide those both by 3, and I get negative 5/3. Okay, in part F, we have k of x equals j of x squared, and we want to find k prime of 2. Because there's a function inside of this other function j, we will have to use chain rule here. So k prime of x is j prime, derivative of the outside, leave the inside the same, x squared, times the derivative of the inside, 2x. Now we evaluate k prime of 2 equals j prime of 2 squared, which is 4, times 2 times my x value, which is 2. J prime of 4, so that was the slope of the graph at 4, that was negative 1/3, times 4 here, and so we just get negative 4/3. Okay, number 3 is a totally separate function. It doesn't have anything to do with the graph up above. So we have f, which is some function, and all we know about f is that f of 4 equals negative 1, and f prime of 4 equals positive 1. So if we let g of x equal 3 times f of x cubed plus 1, we want to find the equation of the tangent line to g at the point x equals 4. So just like always, we need a point and we need a slope. So let's find the point first. So g of 4 means that I have 3 times f of 4 cubed plus 1. So f of 4 was given to me, that was negative 1. Make sure you're looking at the right one, f of 4. So 3 times negative 1 cubed plus 1, that's negative 3 plus 1, which is negative 2. So we have the point for negative 2. To find the slope, we'll find the derivative. So g prime of x equals, so this is chain rule once again. I have the inside f of x, my outside 3 something cubed. The derivative of that 3 something cubed is 9 something squared. That something is f of x. But remember, I have to multiply by the derivative of the inside, which is f prime of x. And then the derivative of the plus 1 is just 0. Now I evaluate g prime of 4. Means I have 9 times f of 4 squared times f prime of 4. And I was given both of those values to plug in. So 9 f of 4 was just negative 1 squared times f prime of 4 is positive 1. So I get 9 as my slope. Now I can write my equation. Y minus negative 2, so plus 2, equals my slope, 9, times x minus 4.